So we just discussed that at an optimal bundle, we'll have that the marginal rate of substitution is equal to the negative of the price ratio, negative P1 over P2. Now to prove to you that this is true, let's consider a case where we don't have that the marginal rate of substitution is equal to this negative price ratio. And remember that the marginal rate of substitution is the change in x2 for a given change in x1. That's rise over run the slope of the indifference curve. So if we have, let's pick some numbers here. Let's say that the marginal rate of substitution is negative 1/2, while the negative of the price ratio is negative 1. So if we're in this case, this is saying that for the consumer is just willing to give up 2 units of x1 to get 1 unit of x2. The negative of the price ratio says the market lets you give up 1 unit of x1 to get 1 unit of x2, right? If you sold a unit of x1, then you'd get $1, which you could use to buy 1 unit of x2. And so you can see here, will this consumer go to the market to sell their x1 to get x2? Absolutely. The consumer is willing to give 2 units of x1 to get a unit of x2, but they don't even have to give up 2 units. They can just give up 1 unit. So they can get their unit of x2 that they want at a cheaper price than what they're willing. And so they gain from this market exchange. So if I'm going to draw this out, we're at a situation like this. Here's x1, here's x2. Here's their budget line. I'm drawing slope of -1 because that's the price ratio. And we're at a situation like this. They have an indifference curve that looks something like this, and they maybe are down here with a slope of -1/2. That's the marginal rate of substitution. That's their slope of the indifference curve. Whereas the price ratio is -1. And so what will the consumer do if they are at a bundle like this? They're going to give up their x1 to get more of x2. And so they're going to, climb up the budget line until they're at their highest possible indifference curve, which is maybe something right like here, where they get that the marginal rate of substitution equal to the negative of the price ratio. And in this case, the market makes an offer like this. The consumer is willing to do something like this, and when these two things are equal, the consumer is just willing to give up a little bit of x1 to get a little of x2, or the opposite. But they're going to stay right here, and in that's the optimal bundle. Now, what if, I have one more thing to talk about. What if, so say we're in this same scenario right here with the marginal rate of substitution. This is getting a little messy. Let me clean this up a little bit. So what if we're still here in this scenario where the marginal rate of substitution is -1/2, the price ratio is -1. What if there's another reason the consumer can't give up x1 to get more of x2? So this is a situation where we can get stuck in in an optimal bundle where these two things are not equal. So what if we're in this kind of situation? X1, X2, here's our budget line, still a slope of -1. And if our indifference curves look something like this, let me make some more of those. Bring this up a little bit. So if our indifference curve is looks like this, then it's possible we could be at, you know, this. So this is the highest indifference curve that where, you know, this bundle gives us the highest utility, and it's still on the budget line. This is the optimal bundle right here. But the reason that we can't give up more x1 to get x2 is that we're already at 0 x1. We can't give up more x1 because we are at the boundary. Right? So it's possible here at the boundary that the slope of the indifference curve could be something like -1/2, while the slope of the budget line is -1. So this situation would be a boundary solution. If we're not, if there's not an interior solution to the problem, then we could get into a situation where the marginal rate of substitution is not equal to the negative of the price ratio. So I just wanted to point that out as a possibility.